Hey everyone, give me a minute here. I'm just putting together the final data for the exam. Okay, so the exam went well. The class average was about an 85. The scores in green show the exam, 2 grades. So we have a bunch of A's and B's, and then we had a little drop off on the end here. And then the blue lines represent the grades on exam 1. So just to kind of show you the differences, we had some students that went up, some students that went down, but those are the grades. Yeah, so unless there's any questions, we're going to move on. Anyone have any questions or concerns? All right. Okay, so let's look at where we are in terms of our schedule. So today is the 30th. And so what we're going to be doing is today is going to be all about quadratic functions. All right, that's all we're going to do today. We're going to see if we can't get through all of this. And then remember that Monday is a holiday. Okay, so Bela, you look pretty excited about that. Yeah, so we will not meet again until next Wednesday. All right, and so we'll come back next Wednesday. Then we have another class, and then we have a third exam. So basically, your next exam is going to be all over quadratic functions. That's all it's going to be about. All right. So this is going to be a very important topic. We start today, and let's get going. So so far in this class, when it comes to functions, we have studied what are called linear functions. And those are things that look like this. We started out with the whole idea of y equals mx plus b, which was a line. And then what we did is we replaced the y with some new notation. We said, let's write f of x like this equals mx plus b, which was still a line, but we had this new notation that just meant that this side of the equation depends on x. So we don't need to get into that. That's what a linear function is. We are now moving on to a new type of function. We now study what are called quadratic functions. And I know a lot of you have seen these in high school, but we're doing them again. Okay, so let me give you a little background first. A linear function, of course, we know when we graph a linear function, we get a line, right? Lines have slopes, and they are useful for certain things. You know, like if you take the problem we had on the exam about the cost of electricity, that's a linear function. But there are a lot of things in the real world that do not behave like lines. And so we have to have a different type of function to describe what's happening. And quadratic functions are a type of function that describes a lot of things. I'll give you a couple of examples. Oh, well, let me show you the quadratic function first, and then we'll talk about some specific examples in the real world. A quadratic function is a function, but instead of having mx plus b, what we'll have is ax squared plus bx plus c. Now here, a, b, c are numbers. And we have that a cannot be 0. So when we're looking at quadratic functions, what's going to let us know that we're dealing with a quadratic function is the fact that we're going to have an x squared somewhere in the function. And that's why we say that a can't be 0. Because if you put 0 in front of this, it kills it off, and then you won't have a quadratic anymore. Now, b and c can be any numbers, including 0. So let me give you a few examples of quadratic functions. This would be an example. So these are examples here. X squared minus 5x minus 6. That would be an example of a quadratic function. And so in this particular example, a, b, and c are equal to different things. Let's see if we can identify them. So can someone tell me what a is? So what's
1.
the front of x squared? Yeah, the number in front of x squared, since it's not there, is a 1. Okay, now normally we won't write that. Okay, 1. How about b?
-5.
-5. And what about c?
-6.
-6. Okay. So that's A, B, and C, right? Those, we've identified the 3 numbers in the problem. Here's another example. F of x equals, how about x squared minus 9? That's quadratic, right? Because you see an x squared there. What's A, B, and C here? So A would be what?
1.
1. How about B?
-9.
Okay, so look at the format up here. A is the number in front of x squared, B is the number in front of x, and C is the number by itself.
Oh, we don't have anything. My
We
bad.
don't have an x, right? So what number do you think we need to put here for B?
0.
0. That means we have nothing in front of the x because there is no x. And then C would be -9. Does that make sense? Questions? How about if I change it and I do x squared plus 7x? Is that a quadratic function? Well, we have x squared, right? So it is quadratic. The number in front of x here would be 1. The number in front of x would be 7. And the number by itself, well, there is no number by itself, right? So this would be 0 for C. One more. Okay, so this is quadratic because we have x squared. The number in front of that x squared is -3, so that's A. How about B and C? We don't have an x, right? So that would mean B is 0. We don't have a number by itself, so that means C would be 0. Is that all making sense? Are there any questions on that?
Will we always have a B and C if there's only an A?
Say again, you'll always have an A, B, and C.
Okay.
It's just the question is, what are their values? If you don't see an X or a number here, then the B and the C are 0. See, here's what's really happening. You could look at this as being plus 0, 0x plus 0, right? Do you see that you could look at this as being this?
Yes.
Yeah, so that's a 0 in front of x and a 0 by itself. So that's why B is 0 and C is 0. Same with this one. You could say, oh, that's plus 0. So that's why C is 0. This one's a little harder. You would have to look at it like this. Plus 0x. So now you have nothing in front of the x. And then here, all 3 of them appear. Does that answer your question, Darshel?
Yes, sir.
Okay. All right, now, so this is what quadratic functions look like in terms of, on paper, what they look like. But what do they look like visually? We know that linear functions draw lines. What do quadratic functions draw? So I know some of you are familiar with this, so maybe someone can help us out here. What? Don't know what they're called? quadratic functions when you graph them?
The parabola.
A parabola. Good. So what do they look like, right? What do they look like? Let's take a very simple example. I'm going to give us a very simple example and we're going to draw it. What if I gave you f of x equals, let's go with x squared minus 2x. That is a parabola. I mean, sorry, that is a quadratic function, right? Here, a is 1, b is -2, and c is 0. If we were to try and graph this, one thing we could do is go back to like old school, and we could do like this thing called a t-table, and we could plug in values for x and see what happens when we plug them in, and then try and sketch it. So let's plug in some values. How about if I plug in 0? What do I get if I plug 0 into this function? So if you replace, if you plug in 0 and you replace all your x's with zeros, you get 0 squared minus 2 times 0. That should give you 0, right? So 0 goes in, 0 comes out. So we can look at that as a point, 0, 0. What would happen if we plug in 1? We get 1 squared minus 2 times 1. That's 1 minus 2, that gives you -1. So when you plug in 1, you get -1. Are y'all following what I'm doing over here on this table? Just plugging numbers in? Yeah? What about if I plug in 2? What do I get? 2 squared minus 2 times 2. 4 minus 4, that's 0. So when I plug in 2, I get 0. Y'all all right with this? Y'all are somewhat quiet today. Y'all all right? Plug in 3. 3 squared minus 2 times 3. That would be 3 squared is 9 minus 2 times 3 is 6. We get 3. So that means when we plug in 3, spits out 3. We're going to do a few more. 4 squared minus 2 times 4 is 16 minus 8. We get 8 here. So when we plug in 4, we get 8. So I'm going to try and draw this. I want to try and see if I can sketch what this thing looks like. So we have these points, 0, 0, that's here. 1, -1 means to the right 1, down 1. 2, 0 means to the right 2, don't go up or down at all. 3, 3 means right 3, up 3. 4, 8, 4, 8 means to the right 4, up 8. 4, 5, 6, 7, 8. So there's just a few points. That's just a few points on the graph of this quadratic function. And can you all tell right away that this is not a line? I mean, it's impossible for this to be a line because a line goes through 2 points and there's no way to do a line through all these points. So the shape of a quadratic function is something different. And it turns out that if I graph this, I'm not going to plug in all the points, but if we kept doing points, okay, what would happen is we would get something that looks like this. It goes like this, comes down, oh, it would go like this, and curve back up like that. It looks like a U, okay, it's curved, okay, it's not a line, it's curved. And this shape is called a parabola. Okay, all quadratic functions look like parabolas when you draw them. Okay, that's what they look like. Now, I told you parabolas appear in the real world all over the place. Okay, so I'm going to give you a few examples. Just to give you a sense that this is somewhat useful in the real world. All right, so one of the places that you could see a parabola is like if we were in a classroom right now, I'd ask someone to come up to the front of the classroom and we would throw like a ball or we'd throw like a marker or something across the room back and forth to one another. But because we're in Zoom, I'm not going to do that. If you were to sit there and throw a ball with somebody, when you throw the ball will travel in a curve, like an arc through the air, right? Every ball that's ever been thrown has always traveled in a parabola shape. So all objects thrown through the air must travel in a parabola. It's not a straight line, right? Obviously, it's not a straight line. It is parabolic. Even if you were to take a gun and shoot a bullet out of a gun, there's a bullet coming out of a gun, okay? If you were to shoot a bullet out of a gun, when it comes out, it will start curving down, and that is a parabola. It may not look like it because it comes out really fast, but it is curving down, which is why military snipers and things like that have to understand the math behind things, because if they're trying to hit a target that's a mile away, they have to know where their bullet's going to be a mile later, because it must drop. So everything moving through the air is going to be parabolic. A baseball player hits ball, goes out of the stadium, it's a parabola. So that's one example of parabolas in the real world. And this actually became a pretty big deal if you look at human history. Think about back in the like medieval days when you had like a castle. That's a castle, I know, it's impressive. And then you know, you have the people that live here are nice, peaceful people, and then you have these people who basically want to break in this castle and take all of their wealth, right, and destroy these people. That's human nature, right? We don't get along. So, you know, you want to storm the castle, you want to start lobbing like fireballs into the castle. When you fire them, you want them to land in the castle, right? You don't want them to be going over the castle or hitting short. You want them to land in certain places. Well, if each of these are parabolas, right? If every single one of these are parabolas, then if you knew the function, right? If you actually knew the parabola, the function that represented that shape, then you could actually pinpoint exactly where you want things to hit. Now, back in the medieval days, they didn't have the math yet. They couldn't do it. But nowadays, okay, like current technology, we can shoot a projectile out of a cannon. The military can do this and hit a target 30 miles away. They can hit a car. If you have a car, they can launch a projectile and hit it 30 miles away. And that's because they understand the math behind the parabola. Okay, so that's one way. Now, everybody here uses cell phones, right? We all use cell phones. So, you know, how does a cell phone work? So let's say we're here. There's me. There's my cell phone. Okay. And then here's my friend who's somewhere else across town with their cell phone. You pick up your phone, you dial, and what's happening there? Well, your phone is sending out a signal in every direction. Okay? In every direction. And somewhere around you, somewhere, I guarantee somewhere around you, within a mile or two from you right now, there's a tower, right? You may have seen these towers, and they have these little like weird boxes on the top of them. Have y'all seen these? They wrap all the way around the tower. No? Here we go. Show you a picture. You know, this looks like a decent picture. Yeah. There we go. Something like this on top of a tower. That's a cell phone tower. So each one of these little things up here, what they're doing, you can kind of, yeah, it's hard to see it, but each one of those is what's called a receiver. And what it's doing is it's catching these signals, okay? And then it reads that signal and it says, oh, it's trying to reach this other person. Well, this person has been sending out signals saying basically, here I am, here I am, here I am. If anybody calls me, here I am. So this will catch this signal, send it out, okay? Send it out and this will receive it, okay? And that's, you know, if you're really far apart, if you're a different part of the country, then it may travel through, or like maybe you call from here to Austin, it might travel through, you know, 30 towers before it gets to that person's phone, but it all happens at the speed of light. So you don't even realize that it traveled through all those towers. So how does a parabola come into play here? Well, these little things up here, if you were to open them up, this is what kind of they look like. Kind of look like this. And they're inside, they have a little curve to them. And that curve is, if you were to look at it, like if we were to cut this and look at it from the top, that curve would look like this. Or let me do it this way. It would look like this. It's the shape of a parabola. And the reason it's a parabola, it's not a circle, it's not a half circle, it's a parabola. And the reason why is because parabolas have this very unique property that if something comes in and bounces off one of the walls, it will reflect back to a certain point. And it doesn't matter where it hits. It can be coming in from anywhere. It will, all these bounce signals will all go to the same point no matter what. And only parabolas will do that. Only a parabolic shape will do that. So this point's called the focus. We're not going to deal with that, but we need a parabolic shape in order to make cell phone calls. Okay, that's the way it works. If you don't have parabolas, you can't do it. And then if you want to call somebody on the other side of the world, let's say we want to call somebody on the other side of the world. Then what we do is we actually have satellites up in space that are shaped like parabolas. Have y'all noticed that before? Like satellite dishes are this weird kind of curved shape. That's a parabola. So what's happening here is the tower's catching the signal. And it's saying, oh, we're trying to get to someone that's, you know, when you put the area code or the country code, it knows I'm trying to get real far away. So instead of trying to go across towers on the ground, which you can't sometimes because there's oceans, right? There might be oceans here. Then what you do is you bounce the signal up to this satellite, which bounces it to another satellite, and they're all parabolic. So they're catching these signals, and then that gets sent down to the ground and then back to this person. And again, that's happening at the speed of light. So you don't even realize it's happening. So without parabolas, we don't have telecommunications. Modern day telecommunications don't exist. One more thing. Have you ever used a flashlight where you have a flashlight and then you can turn the end of it and it changes the beam? It makes it like focused or spread out. What's happening there is you have, like, here's your flashlight. Okay, let's say this is your flashlight. So inside here, which you don't really see, is a light bulb. Okay, so you have a little bulb that's letting light out, right? There's your little bulb. But behind the bulb and around the bulb is a mirror. Okay, there's a mirror back there. If you look at the light when it's off, when you look at it, you'll see a silver reflective material in there. That's just a parabolic, it's a parabolic mirror. And so what's happening is the light is hitting the mirror and bouncing straight out. Straight out. But when you turn that little thing at the end, what that does is it moves the mirror back and forth. So if you move the mirror back and forth, what happens is it changes what happens, and it can make this light reflect out in a different way and spread the beam out like that. So all you're doing is moving the parabola back and forth. So I hope maybe that helps you to at least see that parabolas are somewhat useful. If you want to like conquer other nations, you need parabolas, right? If you want to shoot somebody from 3 miles away, then you need parabolas. If you want to make phone calls, you need parabolas. If you just want to turn your headlights on and see down the road, you need parabolas. So they're very useful. So what are we going to do with them? Okay, what's our goal here? Our goal is I'm going to give you a parabola. I give you a quadratic function, sorry. And then you sketch it. All right. I want to be able to give you any parabola and you draw me the picture of the parabola. That's the ultimate goal. All right. Now, when we were doing this with lines, it was somewhat easy because with a line, all you ever needed was 2 points. And once you had 2 points, you drew a line, it was over. With parabolas, there's a lot more involved. There's a lot more that we have to pay attention to. So I'm going to draw now a parabola, and I'm going to point out some of the important characteristics of a parabola. And we have names for certain things on a parabola. So let's say we draw a parabola, and we know the parabola, let's say, looks like this. Okay, that's not that great. Let me try it again. A little better. Okay. So a couple of things to point out. First of all, there is a very important point on a parabola here. And in this particular case, that would be the lowest point on the parabola, right? That'd be the bottom of the valley, the bottom point on the valley there. That is known as the vertex of the parabola. We are going to need to be able to find that point. For any parabola I give you, you need to be able to find that vertex. And I'm going to actually give you a formula for that. So there will be a formula that I give you for this. So that's good. You just need to know the formula to get it. Now, there's a few other things on the parabola that you need to be able to find. The next thing is these points here. Now, we had those points when we had lines, we had that also. What did we call those points on a line where the line hit the x-axis? What did we call those?
The X-intercept?
X-intercepts. So this is an X-intercept. I'm just going to put X-int, X-int, okay? So we have X-intercepts. And then we also have this point, I'll do it in red right there. That's where the parabola hits the y-axis. And so that is called the Y-intercept. Now, there's one more thing that we need to be aware of, and that is if you were to take a vertical line through the vertex, okay, I'm making it a dotted line. This is not part of the parabola, okay? But if you imagine a vertical line through the vertex, a parabola should be symmetric over that line. Now, my picture is not very good. All right, so let me do something to make it better. I'm going to have a computer graph this for me. There we go. I'm going to copy this. Okay, so if you look at this parabola here, you'll notice that here's the vertex. Okay, I'm just going to put V for vertex. If we go right down the middle, do you all see that to the left of this dotted line is exactly the same as the right? It's a mirror image of itself. It can, if you reflect the left side over the dotted line, you will land right on top of the right side. Do y'all see it's a mirror image, a reflection of itself? Y'all understand what I mean by that? Yes, nod, thumbs up, something, yes? Okay, so every parabola should have that. Now, do y'all see why my picture sucks? Like, it doesn't look like it's a reflection. It's just because I drew it and it wasn't very good. But this vertical line is called the axis of symmetry. And all parabolas have an axis of symmetry. Okay, so for all parabolas, we have to think, it's not like a line, 2 points, draw a line. It's not like that. With all parabolas, all quadratic functions, we need to be talking about vertexes, x-intercepts, y-intercepts, axis of symmetry. Those are the things we want to be able to find, okay? But we're going to run into some problems, all right? So let me show you where we run into some problems. I'm going to go back to this graphing software. Okay. Does everyone agree? Look at that picture right there. Does everybody agree that this parabola has a vertex? Yes, it has a vertex. Okay, there it is. Okay, does it have x-intercepts? Yes, it hits here and here. Does it have a y-intercept? It's hard to see it, but it's actually the same as this x-intercept. This x-intercept is actually both an x-intercept and a y-intercept, because this is where the parabola hits both the x and the y-axis. Do y'all see that? So we have a vertex, we have 2 x-intercepts, and we have 1 y-intercept. Agreed? A vertex, 2 x-intercepts, 1 y-intercept. But what if I change things? So here's where we were, something like that. What if I were to make it a different parabola that did that? Do we have a vertex? Yeah, we have a vertex, right? There's our vertex. Do we have a y-intercept? Yes, there's our y-intercept. Do we have an x-intercept? No, we do not. Okay. So that means that not all parabolas have x-intercepts. Not all of them. What about this? Does that parabola have a vertex? Yes. Does it have a y-intercept? Yes. Does it have an x-intercept? Does it hit the x-axis anywhere? Right there at the vertex, right? So what I'm getting at is no matter what parabola you ever have, no matter what quadratic function you ever have, you will always have a vertex, always. You will always have a y-intercept. There's no way for me to ever draw a parabola, ever, where it doesn't hit the y-axis somewhere. And it's because this thing keeps widening out. The further I go, this just gets wider and wider and wider and wider. So no matter what, you're eventually going to hit the y-axis. But when it comes to x-intercepts, we can either have 2 of them, 1 of them, or none. And that's when things become problematic for us. Okay, so let me summarize that. When sketching quadratics, you will have one vertex always, okay? You're always going to have a vertex. You will have one y-intercept always, all right? But you're either going to have 2, 1, or no x-intercepts. And so this is where, like I said, this is where things become problematic, because we are going to have to determine which of those cases it is. Does that make sense to you? From the pictures we looked at, that you're either going to have 2 or 1 or none. There's no way to have 3, right? Because the parabola is, you know, the shape of the parabola, you can't hit the x-axis more than twice. Okay, one more thing before we start trying to draw these. When it comes to parabolas, you have 2 different scenarios that could happen that I haven't addressed. You could have a parabola that goes like this, or you could also have a parabola that goes the other way. So in the one on the left, we say that this opens up and this one opens down. Okay, that's how we say that. Your parabola can open up or it can open down. Now, there's an easy way to determine which way your parabola is going to open. And it all has to do with that number in front of x squared. Remember the number in front of x squared, we called it a? Where is a? Remember that number in front of x squared is a, right? We identified what a was in all of these. I can guarantee you that it will open up if a is bigger than 0. In other words, if it's a positive number. If the number in front of x squared is positive, we're going to have a parabola that opens up. If the number in front of x squared is negative, we're going to open down every single time. So let's see if we can kind of put these ideas together. I'm going to go back to this graphing software. The software is pretty cool because I can change these numbers. There we go. All of them. So this software allows me to adjust what A, B, and C are. So right now A is 1. I'm going to keep A 1, and I want you to see what happens. What happens is I let A get bigger. What's happening to the parabola? As I let A get bigger. Do you see what's happening? The parabola is becoming narrow, real narrow. If I let A get smaller and then it starts to widen out, and then, come on, there we go. And then if I get to negative, it flips over, and now you have a parabola that opens down. So negative, this is negative A and positive A, negative A, positive A. See that? And then the C actually controls the up and down. Okay, that's going to control whether or not it's up or down. And then the B kind of controls, B is weird. Look at what B is doing. So for us, the main thing that we need to know is how A controls things. A just tells us positive A, it opens up, negative A, it opens down. That's all we need to know. All right. All right, you ready? I'm going to give you a set of steps, a procedure for graphing quadratics. But here it is. Steps to sketch quadratic functions. Okay, here we go. First step. Determine if it opens up or down. That's the first step for doing a sketch. You're just going to figure out, does it open up or down? So that should be easy, shouldn't it? Because when I ask you to sketch a quadratic function, I'm going to give you the function, right? I'm going to give you this. That'll be presented to you. So that'll be given to you. So if I ask you if it opens up or down, all you're going to do is what? What are you going to look at?
We're gonna look at it.
If there's a positive or negative.
Yeah, you just look at the number in front of x squared. If it's positive, it opens up. If it's negative, it opens down. So that first step should be pretty straightforward, right? Would you agree? Okay,
Yeah.
the second step, okay, is to find the vertex. Now, every single parabola has a vertex. We said it, no matter what, every parabola you ever draw will have a vertex. You need to find it. Now, I haven't told you how to find it, right? But I told you there was a formula. So here's the way the formula works. Remember that if you have a parabola, that vertex is the lowest point. If it opens up, it's the lowest point. If the parabola opens down, it's the highest point, right? That's an important thing that we'll need later. Parabolas that open up, the vertex is the lowest point on the graph. Parabolas that open down, it's the highest. So no matter how I draw this, if I draw it this way or the other way, this right here, this vertex is a point. Do you all agree that that's a point that I need to find? And so it's a very special point. So we're not going to call it XY. You know, normally we call a point XY. Because it's the vertex, we're going to label it with a very special character letters. We're going to call it HK instead. That's just the standard convention. So the vertex is a point, HK. Now I give you the formula. To figure out what H is, all you do is take negative B and divide that by 2 times A. Okay, so what the hell am I talking about here? To figure out what this number is for the vertex, you're going to take negative B. So remember we figured out what A, B, and C were earlier? All you're going to do is take negative B. So that means the opposite of whatever B was, and divide it by 2 times whatever the A is. And that will always give you H. That formula actually comes from calculus. You don't need to know where it comes from. I'm just giving it to you. If you want to know why it's that, I would have to explain it using calculus, which I can't explain because you haven't taken calculus. So you're just going to have to take it on faith and be, you know, like, okay, fine. All right, now to figure out what K is, that's the other part of the point, right? It's this part. All you're going to do is you're going to take your original function that you were given and you're going to plug into it H. That means you're going to take this answer that you got for the first part and you're going to plug it into that function. And that will give you what K is. So what happens if you mess up H? Well, if you mess up H, you're going to mess up K too, because K depends on you knowing what H is. So if you get H wrong, K is going to be wrong. So it's important that you do this arithmetic correctly. We will do this in an example. I'm just giving you the steps right now. Okay, so to sketch quadratic function, we figure out, does it open up or down? First step. Second step, we find the vertex. Now, the third step is a step that in all my years of teaching, this is a step that I think only I do. I've never met a tutor or seen this in a textbook or anything where people do this step. I always do the step though, okay? What I want you to do at this point is do a quick sketch. A quick sketch. Okay, so let's think about why I want you to do a quick sketch. What do you know at this point? At this point, what is it that you know? Steps 1 and 2, what have you determined?
If it opens up or down and
Up or down. And you should have the vertex then, right? Also? Yes?
yes.
Okay, so think about this. Let's say, and don't write this down, okay? Don't write this down in here. I don't want you to mix it up with the steps. Let's just think about a couple of scenarios. What if I told you that the vertex, we had found the vertex and the vertex was here, okay? We did step 2 and we found the vertex was there. And in step 1, we knew that it opens up. Then it would have to look like that, wouldn't it? Right? How many X-intercepts do you have? None, right?
One, right?
Pardon?
I thought it was 1, but I guess not.
Yeah, it doesn't hit the X-axis, right? Anywhere in this particular picture? If your vertex is here
Correct.
and the graph opens up, then it doesn't hit the X-axis. Now, what if you had done the problem and you had said, oh, the vertex is here, but it opens down? Then what could you tell me? How many x-intercepts would you have?
Two.
You all right?
2.
2, right? We have 2. What if you do it and you find that the vertex is here on the x-axis and it opens up? How many x-intercepts would you have?
Just
6?
1.
Just 1 in that case, you see? So if you do a quick sketch, what is that going to be able to determine for you?
If it opens up or opens down, or and if there's or if it's on the X-intercept.
Yeah, this quick sketch, the whole purpose of doing a quick sketch is to determine the number of x-intercepts. Remember, we said you're either going to have 2, 1, or none, right? You're either going to have 2, 1, or not any at all. A quick sketch should be able to get you to isolate it and figure out how many it is. All you have to know is the vertex and if it opens up or down. If you know those 2 things, then you can tell me exactly how many you have. That all make sense? That takes us to step 4. Find x-intercepts if you have them. See, step 3 might tell you you don't have any. If you don't have any, you're going to skip step 4. Are y'all clear on that? Step 3 tells you how many you have. If you do not have any, you will skip step 4 because you're going to be going trying to find something that doesn't exist. So skip if you have 0 x-intercepts. Okay, so remember that you want to skip this step if you have none. All right, now the question is, how do we find x-intercepts? Do you all remember how we found x-intercepts with lines? How did we do it with lines? We wanted to find the x-intercept. We set y to 0, didn't we? We set y equal to 0. So if you look at this right here, remember that the f of x is what used to be the y, right? So if I want to find the x-intercept, I have to replace the y with 0, which means I have to set this quadratic function equal to 0. So that's how we find these. We set the function equal to 0. In other words, we're going to take ax squared plus bx plus c and set it equal to 0. And then we will solve this. Now I'm going to put a star next to this because this is going to be the hardest part of the problem. Because what we're trying to do here is solve a quadratic equation. And there's multiple ways to solve quadratic equations. There's a bunch of different ways. And so depending on you and your background, I don't know where you're going to be with this. But I promise you, I will give you something that you will be able to solve it no matter what, as long as you have a calculator with you, okay? So we will find the x-intercepts if we have them. We're going to skip this step if we don't have any. And then we move on to step 5, which is to find the y-intercept. Okay, so to find the y-intercept, how did we find the y-intercept on the line? To find x-intercept, we set y to 0. To find y-intercept, we set x to 0, right? We set x to 0. So to do this, we take f, we take it, and we plug 0 into the function. So we find f of 0. So all you're gonna do is plug 0 in here to this. And then the 6th step is to do our final sketch. And we're done. Okay, I'm going to run through a problem. I'm going to do one following these steps. And then we're going to take our break, and then we're going to come back and we're going to work through several together. Okay. But I just want you to see these steps run through one time. Y'all ready? Here we go. Sketch f of x equals x squared minus 3x minus 4. All right, first thing I'm going to do is what we did before. I'm going to identify A, B, and C. So I'm not going to ask y'all for help on this. I just want you to follow me through this. A is 1, B is -3, C is -4. If you have a question though, or you don't understand something, let me know. Okay, first step, it opens up. The reason I know this is because A is 1, and that's a positive number. So because the number in front of x squared is 1, I know this opens up. So I know that when I go to draw this, it's going to look like this, right? It's going to have a vertex like that. So I know that's the general shape of the parabola. Step 2 is I need to find the vertex. So I'm going to use a formula. H is equal to -b over 2a. Now pay attention to this because this is where students get messed up. When you see -b on top here, this means the opposite of b, right? -b is the opposite of whatever b is. So b for me is -3. So I want the opposite of -3, which is +3. So you could look at it this way. It's minus -3 over 2 times 1. So I'm doing -b. B was -3 already. So the negative and negative will be positive. We get 3 over 2. Which is, on my calculator, 1.5. Now, to find k, what I need to do is take that answer and plug it into the function. So that means I need to replace all my x's here with 1.5. So 1.5, I need to square that, minus 3 times 1.5 minus 4. So again, I'm going to need my calculator to do this. I'm going to take my 1.5 and square it. I'm going to do these one at a time. So this will be 1.5 squared is 2.25 minus, okay, 3 times 1.5 should give you minus 4.5 and then minus 4. Are there any questions on this? Y'all are all right? Getting negative 6.25. So my vertex is a point. That's the H, that's the K. So as a point, it's the point 1.5, negative 6.25. All right, that's the point on my graph that represents the vertex. Third step, quick sketch. And when I say quick sketch, I mean quick. Okay, what I do is I draw this and then I go to my vertex. 1.5, negative 6. That means I go to the right a little bit and then down, right? Isn't that what that means? To the right 1.5 and then down 6. I'm not even going to be accurate with it. I just know I need to go to the right and I go down. So I know my vertex is somewhere down there. I don't care exactly where it is. I just know it's down there somewhere. And my parabola opens up, right? So I know that this thing goes up like this. So how many x-intercepts do I have? 2. There and there. I have 2 x-intercepts. That means that I need to go find them, which means I do need to do step 4. So for step 4, the x-intercepts, I'm going to put here, I have 2. Right? I know I have 2. I have that. I know that because of this. So what I'm going to do is I'm going to take the original quadratic function. Oops. That was the original quadratic function, and I'm going to set it equal to 0. And this is the part that I started earlier, right? Because I said this is where everyone's going to be at a different level. So factoring is one way to solve this. All right, I'm going to factor it. If you don't know how to factor, it's okay. Again, I'm going to give you a formula in a minute when we come back from our break to show you how to solve any quadratic. But for now, this is the way I'm going to do it. I'm going to factor this. And if you can factor, if you're coming from high school and you remember how to factor and you're good at it, I recommend you factor when you can. This becomes x minus 4, only because it's much faster, all right, than the other way. So this factors to be x minus 4 times x plus 1. And then you set each of these factors equal to 0. And you get 2 answers, 4 and -1. These are my 2 x-intercepts. So if you don't know how I factor, don't worry about that right now, all right? Just trust that you will have a way to get to these 2 answers later. I just want to show you how we're going to put this all together. 5th step, I need the y-intercept. And so for that, I'm going to plug 0 into the function, which means I take this function and I replace everything with 0, all the x's with zeros. So I get 0 squared minus 3 times 0 minus 4. Everything goes away except for the minus 4. Any questions? It's time to put it all together. I'll try and do it right here so I can fit it all onto one page. All right, so the way I'm going to do this is I am going to start by putting my vertex. I go to the right 1.5 and down 6.25. So let me make this a little bit bigger. So if this is 1 and this is 2, I might have to extend this out. This is 3, this is 4, this is 5. I'm supposed to go to the right 1.5. That's about right there. And down 6.25. 1, 2, 3, 4, 5, 6. There's -7. Here's -6. So I went to the right 1.5 and I'm going to go down -6.25. So I'm kind of eyeballing this in. This is an approximation, but that is the point, 1.5 -6.25. Questions there? The next thing I'm going to do is I'm going to put my x-intercepts. I should have 2 of them. The first one happens at 4, which is right here. Remember, these are x-intercepts. That's why I'm putting them on the x-axis. The other one is at -1, which should be here. Okay. And then I put my y-intercept, which is -4. That's where it hits the y-axis. So 1, 2, 3, 4. That's about right here. And that's it. That's everything I have to draw the parabola. So here's what I like to do. Okay, this is just my personal way of doing this. I like to put an imaginary line through the middle, that axis of symmetry. I like to put it there to kind of help me draw this to make it look somewhat like a mirror image. And I'm going to start with the left side because I've actually got more points on the left that should help guide me. So I know it's a parabola that opens up. So watch what I do here. Just go like this. Up through here. Try and keep it as smooth, no jagged edges or anything as possible. It doesn't have to be perfect. And then I need the right side to kind of do the same thing as this. So like you don't want to do like that, right? Like that looks ridiculous. You don't want to do like that. That doesn't look right. It has to be somewhat symmetric. So I don't know. It's kind of hard to do. Good enough? Look okay?
Yes.
Okay. So that's the final picture, all right? Now, what I would want on a test is for you to put what the x-intercepts are, label those for me, and to label your y-intercept as points. So I know that it hits at 4, 0, at -1, 0, and at 0, -4, and I have the vertex here. And there's your drawing. Another thing to point out, okay? Do y'all see down here towards the bottom where the vertex is? Do you see how it's curved down there? Do not make it a sharp corner. It's not a V, it's a U. So when you draw it, make sure that you have curvature down there. I will take off. If you draw something like this, I will take off. If you do that, and then like that. See how that's pointed corner? That's not correct. Parabolas don't behave that way. They're curved. There's a totally different function that has a point on it. It's not a parabola though. So make sure you have the curve down there. Okay, what do y'all think? I give you a quadratic. Do you understand the steps as far as what needs to be done? I'm not saying do you understand how to do each step, but do you understand that the 6 steps? Okay with that? Okay, let's take a 10-minute break. I'll come back at 12:15, and what we'll do is we're just going to start doing examples, and I'll give you the formula to solve this. All right, and then I'll give you problems to work on. We'll see how it goes. So take a little break. All right, everyone. I'm going to go ahead and continue. Okay, so I typed this up over our little break here. When it comes down to doing these steps, right? These 6 steps for sketching a quadratic, most of the time, the first few steps are pretty straightforward. Students don't have issues with them. Really, the problems come in when you have x-intercepts and having to solve this quadratic equation. So because everyone in the class is going to be at a different level, even though you can factor, and I encourage you to factor if you know how, I need to give you a way that will work for any student, no matter where you are in terms of your factoring skills. So fortunately, we have the quadratic formula that allows us to find the solutions to any quadratic equation. And you may have seen this before. Here's the formula. The answers to this equation, the solutions are x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, this formula, in order to use it, all you need to know are a, b, and c, which are those 3 numbers that we started this whole thing with. That's why I did that earlier, so that you could see how to identify the numbers and put them in here. And notice in the formula, you have a plus and a minus. This means that you are potentially going to get 2 different answers, which corresponds with the fact that if we have 2 x-intercepts, we should get 2 different answers. Okay, so what I'd like to do is I'd like to go back to the problem I just did, this one right here. And I'd like to take this equation right here, and I'd like to just show you, had we gotten to that step and not known how to factor, how we could have used a quadratic formula instead. So what I would do is I would identify a, b, and c, which I've done at the very beginning of the problem, but I'll do it again. It's 1, -3, and -4. And then all I'm going to do is plug into this formula. So x equals, all right, so somebody tell me what negative b would be for us here.
Would it be +3?
+3, good, because the b that we have for this equation is -3. -3 would be +3. So that's a place where students make mistakes, okay? They'll put -3 here, but here it's not. It's the opposite of -3, which is going to be +3, plus or minus the square root. Now here's another place that students make a mistake. B squared. Now look, anytime you square a number, no matter what the number is, anytime you square it, it'll be a positive answer, no matter what. So every time you use the quadratic formula, this piece right here, that will always be a positive number, no matter what. So we're going to take -3 and square it. That means -3 times -3, and that gives us 9. So I'm going to put that here. Then minus, I like to do it this way. I write 4, and then a. A is 1, so I put parenthesis 1. And then times c, so I'm going to put in parentheses the c, which is -4. Now all of that gets divided by, the whole thing gets divided by 2 times a, and a here is 1, so I'm going to put parenthesis 1, so that's multiplication there. Okay, any questions up to that point? Here's the next part that people make mistakes with, all right? This right here is going to be 9, and then you're going to take away whatever this is. Okay, so we have to multiply these numbers together. And what people do here, they make the mistake, they mess up the sign on this. So I'm going to give you a quick little short way of knowing of how to do this. When you look at this, if you see 1 or 3 minus signs, you're going to subtract. If you see two minus signs, you're going to add. So if you see an odd number of negatives, minus signs, you're going to see an odd number, 1 or 3, you're going to subtract. If you see an even number, like 2 of them, then you're going to add. Now, let me explain what I mean. I'm just going to look at these numbers, 4, 1, 4. I'm just going to multiply all those numbers together. So what is 4 times 1 times 4? I'm not even paying attention to the signs. So what are those 3 multiplied together? 4 times 1 times 4 should be 16, right? 16. So what I'm going to do, because I see 1, 2, I see 2 minus signs, I'm going to wind up adding this number. Okay, I'm going to add that number. So let me write that on the next line. 3 plus or minus square root, okay, 9. And now I know I'm going to add, because I saw 2 minus signs, I'm adding 16 to that. And then all of this divided by 2. Now I continue. Any questions there? I'm going to add 9 plus 16, that's 25. All of this divided by 2, which equals, okay, we need to know what the square root of 25 is. So this is where, again, I don't know where you are with square roots, but the square root of a number is, you're trying to find a number that when you square it, you get 25. So what number times itself gives you 25? Well, hopefully everyone's clear with 5, right? 5 times 5 is 25. Now you can also use your calculator, because when this number is something other than 25, like if it was 23, we would need our calculators. So everyone should be comfortable on their calculator to be able to do a square root. And you can check for yourself that the square root of 25 is 5. So now we write 3 plus or minus 5 all over 2. Okay. Again, something to be real careful with that people mess up. When you do the square root of 25 and you write 5, the square root's gone. That symbol's gone. You've already done the square root, so it disappears. And now we have to deal with the plus or minus. So here's the way I like to deal with it. I look at this as being 2 different answers. One is what happens when I use the plus. The other one is what happens when I use the minus. So let's imagine that this is just the plus now. 3 plus 5 over 2. You have to do the top first. 3 plus 5 is 8. 8 divided by 2, that gives you 4. Now, if I do the minus instead, I get 3 take away 5 over 2. That gives me, let's see, 3 take away 5 is -2 divided by 2. That gives me -1. And I get my 2 solutions for -1, which are the same 2 solutions that we got here for -1. Right? We got the same exact answers. So you can see here, I hope that you can see that the quadratic formula is nice in the sense that you can always use it. The bad drawback to it is that it takes a lot longer, and there's plenty of little places where you can make mistakes. And if you make one little mistake, everything's off. So what you need to do is get to a point where you're comfortable with the quadratic formula and you're not making mistakes. All right, let's do a new problem from scratch. I want us to sketch f of x equals -2x squared plus 8x. Hold on. Plus 5. First thing I'm going to do is just identify A, B, and C. I think it's time to start calling on people. We'll just start at the top. How about Bela? You ready? Bela, you there?
Yes.
Okay,
So
you ready?
yes, for identifying A, B, and C, A is
Yep.
going to be -2,
Okay,
B will be 8, and C
Okay.
will be 5.
great. Okay, now, can you do the first step of the procedure? So what is the first step? What are we gonna do? And then can you tell me what we get?
We're going to fill it into the new formula, but I'm not that far on it. I was still writing it in.
Okay, well, I'm talking back in terms of the steps for sketching the quadratic, these steps. The formula, the new formula I gave you is going to come in on step 4. But in terms of just the general steps for sketching quadratics, the first thing we do is determine if it opens up or down. Can you do that? Can you tell me if this opens up or down?
Is it going to open down?
Yes, this opens down. Why?
Because it's negative.
What's negative?
The A number is negative.
A is -2, which is definitely less than 0, so it opens down. So we know, Bela, that our parabola looks like this, right?
Yes.
Which means that when we look at its vertex, the vertex will have to be the highest point on the graph, right, Bela?
Yes.
Okay, good. All right, Tiffany, you there? Tiffany. Tiffany, you there? You there?
Oh, yes, sorry, I was having problems with my mouse.
Okay. All right, so I want you to help me with the next step.
Mhm.
Do you know what the next step is?
We're gonna try and, sorry, I'm looking at my notes. We're gonna try and find the vertex.
Okay, good. And for the vertex, we're basically gonna need to find two things, right? H and K.
Mhm.
All right, so I gave you a formula for H. Do you have that jotted down or no?
Yes, so
Okay, so what is it?
it's -b over 2a.
Okay, good. So can you tell me what -b is for us in this problem?
-b is gonna be -8.
-8. So do you just look at 8, you change the sign, you make it -8?
Mhm.
Tiffany, had this been -8, what would this have been?
It would have been 8 because
Then 8. Okay, good. And then you say over 2 times a, so that's 2 times a is -2, right?
Mhm.
So we have -8 over -4. What's that? Negative divided by negative should be positive, right?
Mhm.
And 4 goes into 8 twice. We good, Tiffany?
Yep.
That's H. Now, how do you find K?
For K, I have, sorry, I have a giant notebook.
All right, no. I mean, at least you wrote things down. That's good.
So for K, it's instead of like the f of x, it's going to be f of h. So we're going to insert h
Which we
instead.
said was 2, right? We got 2 as our answer.
Yeah.
So that gets plugged into the function.
Mhm.
And that means go to your original quadratic and replace all the x's with 2's. Right, Tiffany? Okay, so now at this point, this is just arithmetic. This is order of operations. We'll do exponents first. 2 squared is 4. So this can be -2 times 4 plus, let's see, this is 8 times 2, that's 16 plus 5. Let's see. We have -8, that's -2 times 4 is -8 plus 16 plus 5. -8 and 16 is 8 plus 5, that gives us 13. So Tiffany, as a point, when we go to graph this, it's the point 213. That makes sense to you, Tiffany?
Mhm.
Okay, good. All right, Cheyenne, you're up. Are you there?
Can you hear me?
I can hear you now. Yep. So do you know what our third step is, Cheyenne?
Hold on. Is it picking up sound?
Yes, yes, I can hear you.
Don't know why it wasn't working with my headphones.
I can hear you okay. Do you know what the third step is?
The third step is the third step's where we convert the equation above, right? Or no, that's the fourth step.
Yeah, that's fourth step is when we go to do the x-intercepts, right?
Yeah.
But do we have any? So this is where we do that one step that I said that I like to do, but most of the time I've never seen people do this before. Quick sketch.
Oh yeah, that's right. The quick sketch.
Quick sketch. Okay. So I'm gonna tell you, I'm gonna draw a little picture here really fast. Okay, you tell me the vertex, Cheyenne. I would have to go to this point. So that means, would I move right or left? To get to that point 213, do I move right or left? I think you're muted. Maybe you're having audio problems. Diane, do you want to help out?
Right.
Okay, so you're going to go to the right 2, right? And then where?
Up 13.
Up 13. So we don't need to be very accurate, just to the right and up is all that matters. Okay, and then from there, Diane, our parabola opens which way?
Down.
Down. Okay, so it opens down, which means that how many x-intercepts will we have, Diane?
2.
2. Okay, we're going to have 2 x-intercepts. So I know now I have 2 x-intercepts. And that means that I actually want to do step 4. I do want to do step 4 because step 4 requires, or step 4 is what we use when we have is what we do when we need to find x-intercepts. Okay, how about Elisa? Is Elisa here? Let's see, Elisa. Katrina?
Yes, I'm here.
Okay, Katrina, are you following this okay?
I think so.
Okay, so we're going to go find 2 x-intercepts. And so to do that, we need to do what?
I forgot.
Okay, so anytime with a quadratic function that you want to find the x-intercepts, you're going to take the function, okay? You're going to take this function and you are going to set it equal to 0. Okay, that's how we find the x-intercepts for a quadratic. We take the original function, just set it equal to 0 and solve this. And this is called a quadratic equation. Now, I designed this problem, it does not factor. Okay, so nobody in here is going to be able to factor that for me, which means you only have one choice, and that is the quadratic formula, which is what I put here on the previous page. So let me copy that and bring it here. Okay, so Katrina, I want you to help me on this, all right? You ready? I'm going to use that formula, x equals. All right, give me what is negative b for us, Katrina?
-8.
Negative 8. So I'm going to write negative 8. Then I'm going to put plus or minus. Square root. Okay, now we need to square the b. So we need to take that 8 and square it. So what's 8 times 8?
64.
So we have 64 here. Minus 4, that will always be a minus 4. And then what's a and what's c? Those two numbers go here.
-2 and 5.
-2 and 5. Okay, great. And then I'm going to divide the whole thing by 2 times what?
-2.
-2. Okay, perfect. All right, that's the setup of the formula. Just one more thing with you, Katrina. How many minus signs do you see over here? Underneath the square root, how many minus signs do you see?
2.
2, right? You see
Yeah.
the 2 right there? And I said that whenever you see 2, that means you're going to ultimately add the number you get here, okay? I said that in the previous note here, that when you're looking at these signs under the root, if you see 2, we're going to wind up adding. So that means I'm going to take these numbers, 4, 2, and 5. I'm not even going to care about their signs. 4 times 2 times 5. And then now, who's taking over at this point? Caitlin, you're up.
Okay, so just the 4 and 2 and 5, right?
Yeah, 4, 2, and 5, that multiplies to be what there?
40.
40. Okay, so let's rewrite this now. X equals -8 plus or minus square root 64. Okay, and now, Caitlin, what comes after the 64?
Plus 40.
Plus 40. And the plus is because we said if we see 2 negatives, we're going to add. So we're going to add the 40, that number. Then all of that divided by 2 times -2 is -4. Okay, Caitlin, I'd like to see if you can add those up together. What
It'd
does
be
that add up?
104.
104. Square root of 104, right? Underneath there, and then over -4. Square root of 104 is not a number that anyone here should know. If it said square root of 100, then of course you can say, oh, 10. 10 times 10 is 100. But we don't know what the square root of 104 is, so we need to use our calculators. So please, if you have your calculator, make sure that you can get this. Do you have a calculator, Caitlin?
Yes, but
What
it's
did you get for that?
104. What, don't you divide that by 2?
Don't do any division yet. Just do, what was the square root of 104 on your calculator?
It's not letting me.
No?
That again.
What kind of calculator are you using?
Right now I'm just using my phone one.
Oh, okay. All right. It's not letting you do it?
Yeah.
What is it doing?
It won't, I don't know where the square root, like it won't have me do any
It
square
doesn't
root.
have a key for square root?
Yeah, I don't think so. Really,
Turn your calculator sideways or turn your phone sideways. Does that change anything?
more show up, but it's all like squared, like square root squared, if that makes sense.
Not sure.
Here, wait.
Do you have a little key that has an arrow on it or
There, press the square root with the 2 on it.
just try it? Just try the,
The one with the 2 on the outside. That's just regular square root.
10.19.
yeah, 10.19. Yeah.
Thank
And
you.
let's round it 2 different decimal
You're welcome.
places. 10.19. Okay, all of this over -4. Now, there's something that I want to point out, another place where students make mistakes. You see this -4 that's been down here this whole time? Do not try and somehow combine the -4 and the 104 together. Do not try and combine the 8 and the negative. Don't do any of that. You're not allowed to, because that division bar is like this big barrier. You're not supposed to touch anything on the top until you figure out everything on the top first. Then you can divide by -4. So Caitlin did the square root of 104 on her phone, got this. Notice there's no more square root symbol. And now at this point, I'm ready to get the 2 different answers. So plus here and minus here. So for the plus, what I'm going to do is -8 plus 10.19. And then I will divide by -4. On the minus, I'm going to put the minus in between them instead. 8 minus 10.19 all over -4. All right, Caitlin, we'll stick with you here. So Caitlin, on the top, if you need your phone, do it's fine. -8 plus 10.19 should give you what?
2.19.
Okay, and then you're going to wind up try and divide that by -4 and tell me what you get.
0.54.
Negative?
No.
You should get negative because you're doing 2.1 divided by -4.
So 2.19. Yeah.
Okay, so it was what? Negative what? Point
Negative 0.54.
54. Okay. Now let's move on to let's see, Jamal, are you here?
Yes, sir.
Okay, do you have a calculator handy?
Yes.
Okay, can you do this one for me? What's -8 take away 10.19?
At the top of the fraction, I got negative 18.19.
Okay, and then divide that by -4. So we should have a negative divided by negative. We should get positive here.
I got positive 4.54.
Okay, 4.54. There we go. We've got our 2 X-intercepts. They're decimals. Okay, big deal. We'll deal with it. Okay, good. All right, so Jamal, we just finished finding the X-intercepts. Jamal, do you know what the next step is after we found the X-intercepts?
Find Y-intercept?
Y-intercept. Okay, so do you know how to find the Y-intercept?
Don't you replace the X with 0?
Yep, exactly. So we're just going to plug 0 into the original function. And has someone noticed something about this step? That when you plug 0 into the function, what you're always going to get as your answer?
The value of C.
The value of C. See, because A is in front of this, B is in front of that, right? So if we replace X with 0, these are all going to go away. All you'll ever be left with is C. Very good. Very good, Dina. So we have 5 here as our answer. All right, I think it's time to put this all together into our picture. So does everyone have this information jotted down? We have our vertex, we have our up or down, it's down, we have our vertex, we've got our X-intercepts, and we've got our Y-intercept. Time to draw it. All right, so here we go. You don't have to use graph paper, just as long as I can tell where things are. Okay, where was the vertex? Start with the vertex. Wasn't it 213? Wasn't that what it was? 213, so I'm going to say 1, I'm going to say 2. Now look, if I go up 13, I'm going to be way up here, right? Off my page. So what I'm going to do is something a little different. I'm going to count up by 2s. 2, 4, 6, 8, 10, 12, 14. You are allowed to do that. Okay, it's called changing the scale on the y-axis. It's okay to do this. So I go to the right 2 and I go up 13, and that's going to be about right there. And that is my vertex. Okay, I have an X-intercept. I have 2 X-intercepts. Where were they again? Isn't like negative 0.54? Was that what you got?
Negative 0.55 and 4.54.
Okay, so negative 0.545, something like that, is almost negative 0.5. So again, we're just eyeballing this. I'm going to put that as negative 0.540 as a point. And the other one, what did you say the other one was?
4.54.
4.54. So here's 4. So 4.54 is about right there. 4.540. And then finally, we have the y-intercept, which was 5. So that goes here on the y-axis. That has the 0.05. There we go. So now what I'm going to do is I'm going to draw this axis of symmetry just to help me draw this. I'm going to start with this left side, and I'm going to try and connect the dots. So I'm going to go like this. Oh, crap. That's not bad. It's actually pretty good. And then the other side, I'm trying to do kind of the same thing. I'm trying to make that a curve and not a point up there. Ah, crap. It was looking good, and I screwed it up. Okay, that's good enough. What I'm hoping I don't see are things like this, you know, where like, let's say you had this, I'm hoping I don't see things like this, you know, that's what I don't want. All right, you want to try and make it as much like a parabola as possible. That's it. We're done. What do you think? Yeah. All right, let's try a different one. Why don't I give you a moment to do the first few steps, like figure out what A, B, and C are, figure out if it opens up or down, see if you can't figure out what the vertex is. Let me give you a minute or two to do that, all right? See if you can get through the first 3 steps through the quick sketch, okay? See if you can do that on your own. Just give you another minute. All right. Let's see what happens here. Gina, you're up. So how about start with A, B, and C?
A is -4,
Okay.
B is 8, and C is 0.
Okay, good. Now, in terms of step 1, what did you determine?
It's going to be down.
It opens down, okay, and that's because A is negative. Second step, vertex. Did you get to that?
Yes,
Okay, what did you get for H, which is negative B over 2A?
it's 1.
Okay, so you put what, -8
-8 over 2 times -4.
Okay, and that should give you 1. Very good. And then for k, you took that answer and plugged that into the function. And what did you get there?
4.
You got 4? Okay, good. Does anybody have a question on that? It's all correct. All right. Step 3, you did a quick sketch. So where did you place your vertex? Just tell me, like, right, left, up, down.
Right, up.
Right and up. Okay, so that's some point here, and it opens down.
Yes.
So how many x-intercepts?
2.
2. Good. All right, good. Did you keep going or no?
Yes.
So for the fourth, because you had 2 x-intercepts, you went ahead and set this equal to 0. Right? Now,
Yes.
just out of curiosity, did you do quadratic formula or did you do something else?
I factorized.
Factored. Okay, so factoring would be super quick if you did factoring here. It would save you all the trouble of the quadratic formula. Go ahead and tell me, how did you factor it? You noticed that there was a GCF there?
Yes.
Okay, so what did you pull out?
2.
The
2x.
2x, okay.
Yeah, okay, but
What
yeah,
did
and
that
then negative 2x and plus 4.
And then you set those both to 0?
Yes.
Now, I'm going to do the quadratic formula for everyone else in a minute, but I just want to show you how this gets you to your 2 answers pretty quickly here. X is 0, and then you just solve these little linear equations. You get x is 2, right? 0 and 2?
Yes.
Okay,
Yes.
good. Now, I'm going to do a quadratic formula. I'm going to do it with the quadratic formula instead, just to show everyone how this would work with the quadratic formula. So if we did quadratic formula here, we would have x is equal to, and then we got to use the formula. I'm going to show it even though I've shown it several times. I'm just going to have it up here. That way I can point to it. Okay, so I'm going to go negative b, which would be -8 plus or minus the square root of b squared, which would be the 8 squared, that's 64, minus 4 times a, which is -4, times c, which is 0, all over 2 times -4. Now, do you all see what's going to happen here because you have the 0 right there? Do y'all see that because there's a 0 here, it's none of this is going to matter, because when you multiply the 4, 4, and 0, you get 0. So all that leaves you with is the -8 plus or minus the square root of the 64 that was out front, all over -8, because 2 times -4 is -8. Square root of 64 is 8, all over -8. And now at this point, we have the 2 different cases. Are there any questions? Almost done here with this stuff. Y'all are okay? See how this is taking longer than factoring? So -8 plus 8, that's 0. Over -8, that's 0. And this one, you get -16 over -8, and that gives you 2. So we got the same 2 answers. Okay, Bonnie, you're up. Thank you, Dina. So Bonnie, what do we have for the next step?
Oh, we have to, what's it called? Do the Y-intercept.
Okay, and so the y-intercept will always be C. Okay, so we're going to do a shortcut now. Yes, we could plug 0 in, but we know that the answer to this is always C. And what's C for us here?
It would be 0.
0. Okay, so our y-intercept is 0. So I think we're ready to draw this. We have the vertex is 1, 4. We have the x-intercepts 0 and 2. Y-intercept is 0. We should be ready to do it. Okay, vertex was 1, 4. So to the right 1, up 4. It's right there. The x-intercepts were 0 and 2. And the y-intercept was actually the x-intercept also, right? It hits here. And so if we do an axis of symmetry, I'm just going to do it in yellow this time. We just need to draw a parabola that goes down both sides like that. So I'm going to force this to look like a U, and then, oh man, that's not that great. Okay, good enough. Questions? You ready for another one? Here we go. Okay, let me give you a few minutes, see how you do with it on your own. This one's going to be a little bit different. Okay, so let's see what happens. Try and get through the first 3 steps. So I just launched a poll. When you get through the first 3 steps, just say yes. Okay. If you get through the quick sketch, Okay, I think that's about half of you have gotten through with it. So let's go ahead and work through this. Let's see, Lily, are you there?
Yes.
Okay. So can you just identify what A, B, and C are for me?
A is 3, B is 6, and C is 3.
Okay, good. Now, Lily, for step 1, determining if it opens up or down, what do you got?
It's gonna open up because 3 is greater than 1.
Yeah, so what I start doing instead of writing up or down, I just draw a little parabola going up like that, and I put a little vertex on the bottom because I know it's going to be like that. That's what I normally do once I get to this point. Okay, step 2, vertex. Right.
So it's h equals negative b over 2a. So h equals negative 6 over 2 times 3.
Mm-hmm. Yes,
And
so go ahead.
for that, I got negative 1.
Good. Okay, perfect. Now, to get K, you take that answer and you plug it in. So let's see, you got to be careful with this because of the negative sign. Did you get an answer for that yet?
I got 0.
Okay, so let's see. When we square negative 1, that becomes 3 times 1. And then we do 6 times negative 1, we get negative 6, and then plus 3. And yes, that is going to turn out to be 0. Good. Very good. So the third step, did you get the quick sketch?
Yeah.
Okay, so where do I put the vertex? Left, right, up, down, what do I do?
Left.
Okay. And then?
And then doesn't it sit on the x-axis?
Exactly, perfect. So it goes to the left, but it stays there, everyone, because of the 0, right? In which way did you say it opened?
Up.
Up. So how many x-intercepts does it have, Lily?
1.
1. And do you know what it is?
I hadn't gotten there yet, but it wouldn't. Yeah, I hadn't
No,
gotten
no,
it.
I mean, you don't need to. You don't, there's no work. See, that's the whole point, is that isn't the vertex the x-intercept?
Oh, duh. Yeah.
It is, right?
Yeah.
This point, negative 1, 0, is the vertex and the x-intercept simultaneously. So Lily, step 4, what are we going to do?
Just find the y-intercept.
Yeah, so we're going to skip this step. Do y'all see that? This is important, okay? This is the whole reason I do the quick sketch, is because why go through step 4 now if you don't need to, right? We already know the only x-intercept that exists is the vertex itself, and so I can skip that. Okay, y-intercept, let's go with it. So what's the y-intercept? The y-intercept, Lily, will always be the c, right? And what was c for you?
3.
3. Okay, so this is going to be 3. So Lily, we're ready to draw this, okay? We'll start with the vertex, which is, you said, negative 1, 0. The x-intercept, which is the vertex itself, so we don't do anything with that. And then the y-intercept, you said, was 3, right?
Mm-hmm.
And now you just come in and try and draw a little parabola that goes through that point and to the right. Make it do the same thing, and you're done. Good, that worked out perfect. Did a good job, Lily. Any questions on that? Sure. Okay, let's do another one. Hold on. Yeah, that was fine. Sorry, I'm thinking. Okay, let me give you some time to see how you do. Try and see if you can get through the first 3 steps. Get to the quick sketch. And again, let me know when you got through the quick sketch by answering the poll when you're done. Just the first 3 steps though. Just so you know, you are going to have decimals for your vertex. Okay, so you just need to use your calculator. And Juliet and Evelyn are the 2 people that are coming up. Juliet, are you ready or no?
Yeah, I think I'm ready.
Okay. All right, so first things first, A, B, and C.
-1, -5, and 28.
Okay. Good. All right, does it open up or down?
It would open down because it's a negative.
Because negative in front of the x squared. Okay, how about for the vertex? This is where things get a little bit weird. You're going to need h, which is negative b over 2a. Can you tell me what negative b is?
It would be 5
5.
over -2.
Yep, 5 over -2. And did you do that on your calculator and get a decimal?
Yeah, it's -2.5.
2.5. Okay, perfect. Now, did you try plugging that into the function?
Yeah.
Okay, this is where things get tricky, I think. So let me write what it is first, and then we can kind of talk through this. All right, so you have to square negative 2.5 first. So when you square, did you square that? Did you try and type it in all together? Or did you do it like one piece at a time?
One at a time.
Okay, so what did you get when you squared that?
The -2.5.
Yeah, the negative 2.5. When you multiply negative 2.5 times itself, you get what?
It should equal 6.25.
6.25, but there's a negative out front, so it should be negative 6.25.
Okay.
Is that okay, Juliet? Does that make sense to you?
Yeah.
Okay, good. And now when you multiply those two together, that's a negative times a negative, so we should get positive. And 5 times 2.5, you should get 12.5, and then plus 28. So then just put all those together. $34.25.
Yeah, that's what I got.
Okay, so we have a very weird vertex. The vertex is negative 2.5, 34.25, like that. Agreed, everyone? Is that right? Okay, Juliet, last question for you. When I go to put this vertex on the quick sketch, I'm gonna go left, right, up, down. What am I gonna do?
You're gonna go left 2.5 and then up 34.25.
So it's somewhere over here, right?
Yeah.
Somewhere up there. And it opens which way?
Down.
Down. So since it opens down, how many x-intercepts are we gonna have?
2.
2. We're gonna have 2 x-intercepts, which means we have to do step 4.
Yeah.
Right? So for step 4, let's see. Evelyn, are you here? I don't think Evelyn's here. Darshell, are you there?
Yes, sir.
Okay, so for step 4, we have to find the x-intercepts. So that means we have to take the original equation function and set it equal to 0, right?
Yes.
Which means we're going to have to use a quadratic formula because that's not going to factor. There it is. So I just want you to help me fill in this quadratic formula, okay?
I'm gonna try.
Okay, here we go. So x will be equal to, all right, what will negative b be for us?
5.
5, okay. Plus or minus square root. Now, what will b squared be?
Let me check 1 second. That's gonna be, let me see. Square root of 5. Is that what you're looking for?
No, we're doing the b squared right there. So that means take your b, which is -5, and just square it. So what's -5 times -5?
Negative 25.
25, and it'll be positive, right? Positive 25.
Okay.
And then we go -4. That's always part of the formula. Now, a is what for us?
-1.
-1, and c for us is
Positive 28.
28. Okay, so real quick look at that.
Okay.
How many minus signs do you see?
2.
2. Okay, so that means you're gonna add, right? You're gonna add. I should probably put all this, sorry, I didn't finish this, all over 2 times a, which is -1. Right, the a was in front, was -1. That's just finishing off the formula. But you're saying because you see 2, you're gonna wind up adding. So take those numbers, 4, 1, and 28, multiply those together. Tell me what number you get. While you're doing that, I'm gonna write this down.
I got 112.
112. So we have the 25 that was there. And because we saw 2 minus signs, we're gonna add. And we're gonna do 112, you said?
Yes.
And then all of that over -2. Which is 5 plus or minus. Now 25 plus 112 is 137, I believe. So all I did there was added those two together. Last thing here, what's the square root of 137? Do you have the ability to do that on your calculator?
Yes, I have 11.70.
Yeah, so let's go just 11.7 will work. No more square root symbol minus or over -2. And then at this point is where I like to split it and do the plus and the minus separately. So 5 plus the 11.7 over -2, and then 5 minus the 11.7 over -2. I'm just going to work these out. This is 16.7 over -2. That's -8.35. And then this one is negative, let me see. -6 what did I do there? I messed up. Oh yeah, 6.7 over -2 is -3.35. Darshelle, does that all make sense?
Yes, sir.
Okay. So
I got one question.
Yes.
You know what we multiplied the 4 times 1 times 28?
Yes.
And you said because we have 2 minus signs, we would multiply everything after that first number.
No. When you see 2 minus signs, that just tells you that when you get this number right here, you're going to wind up adding it. If you saw 3 minus signs or 1 minus sign, this would be a subtraction.
Okay. So 2 or more will be added.
Not 2 or more. If it's 2,
oh, just 2.
If it's 2, you add. If it's 1 or 3, you subtract.
Okay. Okay, gotcha.
All right, good. Let's see. I think we got through mostly everybody here. Let's see. How about Lewis? Is Lewis here? I don't see Lewis. Okay. All right, well, I'll do step 5 then. Step 5 is the Y-intercept. That's just the C, so that's 28. And I'm ready to draw it. I better go to a new page for this. All right, I need to refer back. I'm gonna start with my vertex. The vertex was -2.5, 34.25. -2.5, 34.25. Let me just write down the information. The X-intercepts were -8.35 and -3.35. Those are my X-intercepts. My Y-intercept was 28. This is my vertex. All right, so this is going to be kind of a pain in the ass to graph. I think I'll count by 2s going up.
Professor, isn't
Yes.
the 3.35 supposed to be positive?
Positive, did I mess? Oh, yes, it is positive. Thank you. Thank you so much. That's positive, everyone. Sorry about that. So this is positive. All right, good. So to get my vertex, I got to go up 34. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 28, 32, 34, 36. So that's 36. Negative 2.5, 1, 2, there's negative 2. There's negative 3. So I'm going to go to the left 2.5. I'm going to go up about 34.25. I'm just going to ballpark this right around there. That's my vertex. My x-intercept is negative 8. 4, 5, 6, 7, 8, 9. There's negative 9. So negative 8.35, somewhere around here. And then the other x-intercept is 1, 2, 3.35. That's going to be around here. Who told me that I messed up the sign on that? Who brought that up?
Oh, it was Elisa. Is me.
Okay, Elisa, so I'm glad you brought that up, but let me show y'all something. If I had accidentally made that mistake, then my x-intercept would have been right around, let's see, 1, 2, 3, it would have been here, okay? If Elisa had not shown that I made a mistake there, do y'all see that if I would have had my 2 x-intercepts here and my vertex here, do y'all see that when I went to draw this, I would have a major problem? Because I would have these, like, it would be really hard to draw this because it would come down like this, but then this other side would like go like that. It wouldn't look right. So that would be a good indication that something went wrong. So I guess when you're doing yours, if you notice something seems off, go and double check your x-intercepts. Y-intercept was 28, it's 36, 34, 32. It's right there, that's 28. And now I just draw. Okay. That looks like a V. Curve that a little more. There we go. All right. Y'all okay? What I'd like to do now is take a look at the homework because I want to make sure that you can handle this. Let me see here. Schedule. $105. Okay, so for your homework, it is page 105. Y'all can skip number 1. Don't worry about that. Do numbers 2 through 6. But don't worry about number 7. Okay, so you're just going to do 2 through 6. Now, don't worry about what they're asking for. Okay, don't just ignore their things here. All I want you to do is take those problems, numbers 2 through 6, and do them exactly the way we were doing them in class. Go through those 6 steps. Is that clear? And that's it.
Yeah.
Let's call it a day. All right. Everybody have a great weekend. Have a good 4th of July. I will see you next Wednesday, right? Enjoy your holiday on Monday.
Will that be our exam Wednesday or the following Monday?
What? There's no exam on Wednesday. It's the following Monday, July 12th.
Okay.
Yeah.
For the exam, when we take it, are we going to have to know all of the formulas, or are we going to be able to have them on the test?
Yeah, so what I'm gonna do on this exam coming up is I'm going to allow you to have a reference sheet that you can write down the steps in the formulas, okay? But you can't just work out problems on your reference sheet. It'll be strictly formulas and procedures. So you can write down the 6 steps. You can write down the quadratic formula, you can write down the vertex formula. You can say, hey, don't forget to check this, quick sketch, you know, give yourself notes, but you just can't have worked out problems. So you will have that on this next exam.
Thank you.
You're welcome. Any other questions?
That was it. Thank you.
Okay, have a good one.
Thank you, Yoza.
Thank you. Bye.
Thank you,
Thank
sir.
you.
Have a good one.
You too.
Thank you.